It's my second task in Spark Foundation, the task which is regarding prediction using unsupervised machine learning model. Here I have used the dataset of Iris dataset, which is available in sklearn library, but here I have used from Gaggle. Since I have some problem in sklearn library, so I have used from Kaggle datasets. The problem I'm going to do here, predict the optimum number of clusters and represent it visually. Okay, so first I'm importing the libraries. After that, I'm importing the data set. I'm giving it as a name as data. So I'm seeing the first 5 rows, the head. So as you see the head, I have defined there header as none. If I didn't give header as none, it will take the first row as the header value. So I gave header as none. After that, I have gave the header column, which is the column name. The column name I have defined sepal length, sepal width, petal length, and petal width. The last one species, which is the type of flower. And then here the last 5 rows. Now you can see the column name has changed. It is sepal length, sepal width, petal length, and petal width, and species. And data.shape, we have 150 rows and 5 columns, and its size are 750 elements. Since I have marked it 600, something wrong. And there to the statistics of the data, we can see data.describe the count, mean, standard deviation, minimum, and 25 percentile, 50 percentile, 75% and maximum. So you can see 150 data are there in each and every column. And then I'm checking whether it's there we have any null values or not. For checking that, data.isNull.sum. So it's clearly seen that I don't have any null values since it's 0. So I'm cross checking it with not null. So if not null values, so overall length I do have for each and every column is 150. And then the summary of the data, in the summary of the data itself, I can able to get all the data like each and every column, and then the data wise, and then the data types, the sepal length, sepal width, petal length, and petal width are all in floating values. And species alone, it's an object. So I have to see how many duplicates are there. So to find the duplicates, I am using data.duplicated.sum. So I can able to see 3 duplicate rows. Now I'm going to remove the duplicates. So I'm doing drop duplicates in place equal to true. Data.shape of 0, which is 147 after deleted. And then I'm checking the outliers. So here I'm doing in for loop. I have to see each and every time. So I'm using for loops and columns. For each and every column, I am doing for the 4 columns. So whether it is float, I have to check. Since all the data types are float for the 4 sepal length, sepal width, petal length, and petal width. So I'm using this data type equal to float, and then I'm going to put for a box plot. So in this box plot, we can clearly see that sepal length has no outliers and sepal width has few outliers. Petal width and petal length has no outliers. So I'm going to treat the outliers using IQR rule, the Q1 and Q3, the percentile, data of sepal width, which is I'm going to do for sepal width. So in a quantile range, IQR, and then lower fence, upper fence, and then date of sepal length. I am just reassigning the value of sepal width column. I'm applying the function as the upper fence as a upper limit and lower limit. So lower fence will be 2.05, upper fence will be 3.55. Here the box plot has clearly seen that we don't have any outliers after restricting the boundary with lower face and upper face of IQR. And then I'm going to set the target class. The target class, which is the species, the last one, the value of the count, we have Iris versicolor 50, Virginica 49, Setosa 48. And I'm seeing the box plot also by using Seaborn. And then now describing the data again. So you can see the clearly the we have 147 rows since we have deleted 3 duplicate rows. And then here uh, I am going to see the unique column names. So in the species, no, in the species I have unique values like Iris setosa, Iris versicolor, Iris virginica. All are a object, which is varchar. Where and then the distribution of features, for this I'm using for loop. In this for loop I'm using the KD plot. The KD plot, you can clearly see if the species is versicolor, I'm going to give blue color. If it is versicolor, green. If it is virginica, red. So here are the KD plot. So blue, green and red. So if some points are plotted in this region, we can't say whether it is iris setosa or iris versicolor. The same for here also. Okay. So it is all correlated. Some points will correlated there. And then we can see, wait, in the second plot, the same as sepal width also. But in petal length and petal width, the first one, setosa is separate, which is apart from the remaining two. So from this we can conclude that we can't distinguish a species based on sepal length and width. But by using petal length and width, we can say that setosa is separable. And then the correlation matrix. In the correlation, we can clearly see the matrix of this, like the positive correlation and negative correlation, and it is very useful in seeing using heat map. By seeing the heat map, I can say that petal length and petal width are 96%, which is highly correlated, and sepal length and petal length are also highly correlated. In the K, and then we are going to use cluster. K means clustering. From sklearn.cluster import K means. So I'm using elbow method within cluster sum of squares. So sum of squares are defining it as SSE for each and every range of like 1 to 9. Since 10 is the outer boundary, in the for loop the range 10 should not consider. So 1 to 9. The K means cluster. I am appending each and everything inside the SSC list using inertia and using elbow graph to find optimum number of clusters. In this cluster, we can see the optimum number of K, like all the dotted points. Here see after 3, it's moving like this. So the optimum value of K would be 3. As we see that it is increasing in the number of clusters. So after 3 only it is increasing. Values decreases, we select the value for K on the basis of the rate of decrease. So the rate of decrease means the values also decreases. So initializing K++ cluster. In K++ cluster, we can see that I'm feeding the data in the location 0, 1, 2, 3, 4, which is I will get used to get 3 clusters, which is n cluster, which is equals to 3. So I get 3 clustering on 4 columns. Okay. So then K means labels. So I'm labeling, seeing the labels. So they have labeled it as 1, 0 and 2. So some of the clusters have merged it. So we can see the cluster in the separate data column. So I'm adding the cluster column in the data table. So K of cluster, and we can see the cluster values. So how many clusters are there? We have in 0 we have 61, 148 and 238. So these are the cluster values. But see in versicolor it's 50, but it has predicted 61. And in virginica it's 49, it's 48. So it's almost similar. And in Setosa, it's 48 and it's 38. So visualizing the cluster. By visualizing the cluster, in the predicted cluster, we can see by the centroid, I have make a point of the centroid. So this is separate, which is separate from the um, remaining two clusters. So this one is separate point, and this is some of the data points are merging with one another. And then in the species of Eris setosa, I have 100% accuracy since I have 48. All the 48 are predicted right. And in this Eris versicolor, see I have two. They are predicted 50 as correct and 2 as wrong. And then in Eris virginica, 13 as predicted wrong, which is 1/1 correlated. And then here species encoded, I have defining a way. I'm just label encoding for the species, defining in the variable as species encoded. The data species, I'm applying the rule as if it is setosa, put 1, or else virginica, put 2, or else put 0, which means um, setosa, virginica, and what else I missed? Versicolor. Yeah, for versicolor, it is 0. So after that, I'm just seeing the classification report. From this classification report, you can see that the one, what is one here? It is setosa. So setosa got 100% accuracy, and for 0, versicolor and virginica got 86% accuracy and 83% accuracy, which is also good. So at last, from SQL and matrix confusion matrix, you can see this. See, 13 has predicted wrong and 36 has predicted correct. Here, all the 48 are predicted correct for the one, which is setosa. And then on virginica, 48 predicted correct and 2 predicted wrong. So in the conclusion, we can know by then the bell curve whether if it is setosa ends roughly at 2.1. So the petal length is less than 2.1. We can say it is setosa. It's greater than 2.1 and less than 4.8. We can say versicolor. If it is greater than 4.8, we can say it is virginica. That's all. The task 2 has completed. Thank you.